Hey everyone, this is Sarthak and welcome to the channel FUNDA CHEMISTRY. So in this lecture, I'll be discussing about your chemistry of lanthanides and actinides. Alright, so before proceeding towards the topic, let's have a look on your periodic table. Okay, so this is your periodic table. Okay, here in the left side your S block elements are present. This is your S block. In the right side your P block elements are present. In between S and P block your D block elements are present. This is your D block elements. The D block elements are called transition elements because their physical and chemical properties are intermediate from S block and P block properties, and also these elements act as bridge from S block to P block, and hence they are known as transition elements. Transition elements are classified into four series, that is your 3D transition series, that is from scandium to zinc 3D transition series, and 4D transition series from ytterbium to cadmium. Then your 5D transition series, this is your 5D transition series, and this is your 6D transition series. Alright. So look at 5D transition series. This is your 5D transition series. Here in between lanthanum and hafnium, see, lanthanum and hafnium, there are 14 elements are missing. Similarly, in case of 6D transition series, that is your actinum and rutherfordium, this is your rutherfordium. Alright, there are 14 elements are missing. So here the question is, where did the 28 elements go? The answer is very simple. These 28 elements have been arranged separately in the periodic table, that is in the lower part of the periodic table. Alright, these elements are called A block elements and are also known as inner transition elements. Okay, so the first series of 14 elements lies between lanthanum and hafnium in 6th period, that is your cerium to lutetium. The elements of first series are called lanthanides or lanthanones and are also known as rare earth elements, while the other series of 14 elements lies between actinum and rutherfordium. This is your rutherfordium. Alright, the second series are called actinides or actinones and are also known as 5F series. The name lanthanides and actinides has been given since these elements follow lanthanum and actinum respectively, with which these elements show close similarities. Okay, so the question is how to remember A block elements. Alright, you can remember A block elements by the following mnemonics. So for the first series, that is your lanthanide series, you can remember in this way. That is your सीमा पर लड़ो पीएम समान, यू गद्दर तबाही दोबारा होगी और तुम यहाँ लूटोगे. ठीक है, और you can remember in this way also, सीने पर नाम परमात्मा समाया, यू गदगद तब दिल हुआ, अरे तुम ये भी लूटोगे. I am repeating once again, सीने पर नाम परमात्मा का समाया, यूं गदगद तब दिल हुआ, अरे तुम ये भी लूटोगे. This is for your lanthanide series. To remember actinide series, you can follow this mnemonics, that is थोड़ा प्लेयर्स उनसे निपटेंगे, पुराने आम कम बिकेंगे, फेंक दो इसे, फरमाओ मैडम नाश्ता लाओ. Alright, so these are the tricks to remember your A block elements. Okay, now we will discuss about what is A block elements. Okay, the elements in which last electron enters in F subshell of anti-penultimate shell are called A block elements. In lanthanide and actinide, the additional electron goes to N-2, that is your anti-penultimate shell. This is your ultimate shell or valence shell. Next to your ultimate shell, that is your penultimate shell, and next to penultimate cell is called anti-penultimate cell. Alright. Here the electron goes into the anti-penultimate cell, hence these elements are called A block elements. Since the extra electron goes to the f orbital, this is the reason why it has been called A block elements. Alright. In lanthanides, the 4f orbital is being gradually filled, whereas in actinides, 5f orbital is being successively filled one after another. So next is your classification of inner transition elements. So the inner transition elements, that is your A block elements, have been classified into two following series, that is your lanthanides or lanthanones and actinides or actinones. The 14 elements from cerium to lutetium are the members of this series are called lanthanides. These elements are called lanthanides since these elements are placed after lanthanum in group 3 and period 6 of the periodic table and show some close similarities with lanthanum. Lanthanides, the last electron enters into the 4f orbitals, that's why they are also called as 4f series. The elements of lanthanides, that is your cerium to lutetium, have similar properties, that's why they have studied in a period separately. Okay, lanthanum is the prototype of lanthanides. Lanthanides are also called as lanthanones or rare earths. The name rare earth was given to them because they were originally extracted from oxides, for which ancient name was earth and which are considered to be rare. But the term rare earths is now avoided because many of these elements are no longer rare, but they are abundant now. That's why they were called rare earth elements. Alright. So next, talking about your actinides, the 14 elements from thorium to lawrencium are the member of this series and are also called as actinides. These elements are called actinides since these elements are placed after actinum in group 3 and period 7 in periodic table and show close similarities with your elements, that is your actinum. Since the last electron enters into the 5f orbitals, the actinides are also called as 5f series. In case of f orbital can accommodate 14 electrons, hence each of two series of inner transition element consist of 14 elements. Alright. So next is your position of lanthanides in periodic table. All the 14 elements of lanthanides have atomic weights between those of barium and hafnium, and therefore they must be placed in between these two elements. Alright. In case of your actinides, all the 14 elements have atomic weights between those of strontium and rutherfordium. Hence, they must be placed between these two elements, as was also proved by Mosley. Okay. Now let's talk about some common properties of lanthanides. The first thing, that they all are metals. They are relatively soft metals which can be easily cut with a knife, which is similar to the properties of group 2 elements. Okay. They are silvery white in color. It is good shining as metal. Alright. The 15 elements from lanthanum to lutetium are lanthanoids, whereas 14 elements from cerium to lutetium without lanthanum are lanthanides. Okay, they are called first inner transition series and come immediately after lanthanum. The reactivity of the elements is greater than that of transition metals and comparable to those of group 2 elements, that is your calcium, barium, magnesium, strontium, etc. They are highly reactive. They liberate H2 gas when reacted with water. They are classified as A block elements along with actinides. They are commonly called the rare earths. They are characterized by the filling of the 4f energy levels, which are not usually involved in bonding. In lanthanide series, promethium is the only radioactive element. Okay. Now let's talk about some useful applications by lanthanides. Alright. Lanthanides have broad scientific and industrial applications. It is used as catalyst in the production of petroleum. They are often used in laser, motion picture projectors, and X-ray screens. Some lanthanides are combined with iron to create flint for cigarette lighters. Flint means that it's going to spark before ignition of flame in the lighter. So in this chapter we will discuss about the following properties of lanthanides, that is your electron configuration, oxidation states, atomic radii, color and magnetic properties, and chemical reactivity. So we will first study about the electronic configuration of lanthanides. First property is the electronic configuration of lanthanides. Alright, the general electronic configuration of lanthanides can be written as xenon 54, 4f2 to 14, 5d0 to 1 and 6s2. This is your general electronic configuration of lanthanides. Electronic configuration of lanthanum and 14 lanthanides are given in this table. You can see here. Okay, suppose I am taking barium, which atomic number is 56. The general configuration of barium is xenon 54 and 6s2. The next element after barium is your lanthanum 57. The electronic configuration of lanthanum, according to above principle, the 57th electron must enter 4f orbital to give 4f1, 5d0 and 6s2. But in lanthanum, the energy of 5d orbital is lower than that of 4f orbital. Okay. Thus, the electronic configuration of lanthanum is 4f0, 5d1 and 6s2, not 4f1, 5d0, 6s2. Alright. This is so the electronic configuration of lanthanum is xenon 54, 4f0, 5d1 and 6s2, which is predicted by above principle. Alright. When we move to cerium, cerium has different electronic configuration. The electronic configuration of cerium is xenon 54, 4f2, 5d0 and 6s2. This is because of all the 2 electrons are entered into the 4f orbitals of cerium. That's why cerium has different electronic configuration than that of lanthanum. So in 4f transition series, the electrons are successively filled in the 4f orbitals up to lutetium. Except gadolinium and lutetium, other lanthanides have empty 5d orbitals. You can see here in the table, see the 5d orbitals have 0 electrons except your gadolinium and lutetium. This is due to the stable configuration of gadolinium. This is half filled, and in case of lutetium, the 4f orbitals are full filled. You know, half filled and full filled orbitals are more stable. That's why they prefer this electronic configuration. Okay. So the general electronic configuration of lanthanides can be written as xenon 54, 4f2 to 14, 5d0 to 1 and 6s2. Alright. All the lanthanides have been allotted one single position in the periodic table on the account of great similarity in their electronic configuration and chemical properties. This is all about your electronic configuration of lanthanides. In the next video, we will discuss about the other properties of lanthanides. Okay, thanks for watching.